All right, this is the last question. Well, that somebody told me about at least from the CRs. This is problem 3.71. This is the basketball shot question. And just to give you an idea of the picture, the ball starts here and goes up and into the basket. This is the player's hand right here, and it's the backboard of the rim. So based on the information that's given, for me, again, this is my information, delta y is 3.05, which is the height of the rim, minus 2.4, which is the height of the player's arm, or where the ball leaves from. So that's 0.65 meters. And the question is, how far was the player if he made the basket? And you know that V initial, maybe I'll draw this over here, the ball goes at 11 meters per second and at an angle of theta, looks like 36 degrees above the horizontal. So first things we're going to do, from that we can find V initial in the X and V initial in the Y. Again, verify my work, but I got 8.9 meters per second and 6.5 meters per second. This is another complicated question in that you have to use the quadratic. We need to figure out the time in the air in order to figure out delta x, because delta x is V initial in the X times t. We know this, but we don't know t, so we're going to get t from the delta y equation, which is V initial yt plus 1/2 ayt squared. Plugging in, I'll write it as quick as I can, 6.5 without units times t minus 4.9, plugging those in there, t squared, and delta y we just said was 0.65 meters. So you do that, and I got t was equal to, you actually get two answers, 1.22 seconds or 0.1 seconds. I hope you don't pick 0.1 seconds. If you want to know the meaning of that, this equation tells you the change in y as a function of time. So after 0.1 seconds, the ball is 0.65 meters above where it started. Where's that in your picture? That would be right there, which obviously is not going through the hoop. So another, well, total of 1.22 seconds, it's also at that same height, but that's where you want it to be. So we'll choose that t, we'll plug that into delta x. V initial in the x we said was 8.99 times 1.22, and you get 10.9, or if you're using sig figs, 11 meters is your answer. So that's part one. Part two wants to know what is the angle that the ball goes through the hoop. Let me get a new slide here. So the angle it goes through the hoop, if you think about it, here's the hoop, here's the ball coming down through the hoop. In order to figure that out, you need to know what's the V final in the X and the V final in the Y. V final in the X is pretty easy. It's V initial in the X because AX is equal to 0. So that's just going to be your, what was it, 8.9 meters per second. V final in the Y, a couple ways to do it. I'm going to pick the easy one. We've solved for time before, so I'm just going to do V initial in the Y plus AY times T, which is, what did I say this was, 6.5 meters per second minus 9.8 times 1.22 seconds gives you negative 5.46 meters per second. So that is that. That is that. Does that negative make sense? It better because of that there. So how do we find this angle? Let's solve for this one below horizontal. If you make your triangle, translate this V final in the Y over to there. It looks like, and I'll scribble it in here, tan theta equals V final in the Y divided by V final in the X, which if you do the math on that, theta is equal to about 31.5 degrees below horizontal. And there's your answer.